My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Data Mining as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: what is classification? Classification is a data mining technique used to group data into fixed categories based on patterns. It works like a teacher checking exam papers and deciding whether each student gets pass or fail. The computer learns from old data, called training data, and then uses this learning to classify new data. How it works? 1. Give the computer some examples with labels. 2. It studies the patterns. 3. It predicts the correct group for new, unseen data. Example, easy to remember. Imagine a bank wants to know whether a person should get a loan or not. It uses past data like salary, age, job type, and repayment history. Then it classifies new applicants as eligible or not eligible. Why it's useful? Helps in decision making. Saves time. Reduces human errors. In short, classification is equal to teach the computer plus computer learns patterns plus computer predicts the right category. Next important short question is: 2. What is prediction? Prediction is a data mining technique used to guess future values based on past information. It is like looking at old trends to estimate what might happen next. Unlike classification, which puts data into categories, prediction gives a numerical value. Simple explanation. The computer studies old data, finds patterns, and then uses those patterns to predict a number like sales, marks, temperature, or expenses. Example, super easy. A mobile shop owner wants to know next month's sales. He has past data for 12 months. Using prediction, a computer analyzes trends, festive seasons, discounts, customer demand, and predicts that sales may be around 2,000 units next month. Why it's useful? Helps plan budgets. Reduces risks. Supports smart decision making. In short, prediction is equal to use old data to guess future numbers. It's like checking last year's cricket scores to estimate how many runs a batsman might score today. Next unit 3. Long questions. First important long question is: issues regarding classification and prediction. While classification and prediction are powerful techniques in data mining, they also come with several challenges. Understanding these issues helps us build better and more accurate models. 1. Data quality issues. If the data contains missing values, spelling mistakes, or errors, the model learns wrong patterns. Example, if students' marks are recorded incorrectly, the model may predict wrong results. 2. Noisy or unclean data. Sometimes data contains outliers, very unusual values. This noise confuses the model. Example, a salary record showing 10 crore rupees instead of 10 lakh rupees may mislead a loan prediction model. 3. Too many or too few attributes. Having too many features slows down the model and creates confusion, while having too few makes the model weak. Example, predicting house price using only area is not enough, but using 100 unnecessary features also harms accuracy. 4. Imbalanced data. If one class has far more examples than the other, the model becomes biased. Example, if 95% of patients in a dataset are healthy and only 5% are sick, the model may predict healthy for everyone. 5. Overfitting and underfitting. Overfitting, model learns too many details and performs well on training data but fails on new data. Underfitting, model is too simple and cannot capture real patterns. Example, a student memorize answers, overfitting, versus barely reading the textbook, underfitting. 6. Choosing the right algorithm. Different problems require different algorithms. Selecting the wrong one reduces accuracy. Example, using linear regression to predict categories, like pass-fail, will give poor results. 7. Long training time. Some models take a lot of time to learn from huge datasets, especially decision trees, neural networks, and random forests. 8. Interpretability. Some models are black boxes, meaning we cannot easily understand how they make decisions. Example, neural networks give accurate results, but are hard to explain to teachers, doctors, or bank officers. Easy to remember line. Good data plus right model is equal to good prediction. Bad data plus wrong model is equal to confusion. Next important long question is 2. Decision tree induction classification. A decision tree is one of the simplest and most popular classification techniques in data mining. It works like the way we humans make decisions, by asking questions step by step. The tree has nodes, questions, and branches, answers, that finally lead to a decision class. What is decision tree induction? Decision tree induction is the process of creating a decision tree from training data. The system looks at past data, finds the most useful attributes, and builds a tree that can classify new data easily. How a decision tree works? Simple steps. 1. Choose the best attribute. The system picks the attribute that splits the data most clearly, like income, age, marks, etc. 2. Create a decision node. This node asks a question based on the chosen attribute. Example, is the salary 30,000 rupees? 3. Split the data. According to the answer, yes, no, the data is divided into branches. 4. Repeat the process. Keep creating nodes until you reach a final decision, leaf node, like eligible or not eligible. Easy example, loan approval. A bank wants to classify if a customer should get a loan or not. Sample data attributes. Salary, age, job stability, credit score. Decision tree may look like 1 is credit score 700. Yes, check salary. No, not eligible. 2 is salary 30,000 rupees. Yes, eligible. No, not eligible. This simple flow helps the computer make correct decisions for new customers. Advantages of decision trees. Very easy to understand. Works with both numbers and categories. No complex mathematics. Quick classification. Disadvantages. Can overfit if the tree is too large. Small change in data may change the tree. Not good with noisy data. Easy to remember trick. Decision tree is equal to step-by-step questions, simple answers, final decision. Next important long question is 3. Explain Bayesian belief network with an example. Bayesian belief network, BBN. A Bayesian belief network, also called a BaseNet, is a model that shows how different things, variables, are connected and how one thing affects another. It uses probabilities to predict the chances of an event. Think of it as a smart map of relationships, where arrows show how one condition influences another. Why is it called Bayesian? It is based on Bayes' theorem, which helps us update our belief when we get new information. Example. If you hear thunder, your belief that it is going to rain becomes stronger. Main features of BBN. 1. Nodes represent variables, like rain, traffic, fever, etc. 2. Arrows, directed links, show relationships. 3. Probabilities. Each node has a chance, probability, of happening. 4. Conditional probability table, CPT, shows how the probability changes when parent nodes change. Simple example, easy to remember: cold, fever, and headache. Let's say a student may have these symptoms: cold, fever, headache. We want to predict whether the student has flu. A Bayesian network might look like this: cold, flu, fever, headache. Explanation. If someone has cold, flu becomes more likely. If someone has fever, flu becomes more likely. If someone has flu, then headache is more likely. How it works? Suppose a student has fever and headache, but no cold. The network will combine these probabilities and calculate the chance of having flu. Even without cold, fever plus headache increases the flu probability. Why Bayesian networks are useful? They work well even when some data is missing. They show clear relationships between variables. They handle uncertainty better than many other models. They are easy to visualize and understand. Real-life uses: medical diagnosis, weather prediction, fraud detection, machine learning decisions. Easy to remember line. Bayesian network is equal to connections plus probabilities, smart predictions even with uncertainty. Next important long question is: 4. Discuss briefly about rule-based classification. Explain with advantages. Rule-based classification. Rule-based classification is a data mining technique that uses a set of if-then rules to classify data. These rules are simple statements that tell the computer how to decide the class of a new item. It works just like how teachers make rules for students. If homework is complete and attendance is good, then allow extra marks. In classification, these rules come from training data. What is an if-then rule? A rule has two parts. 1. If condition checks some features. 2. Then class gives the category. Example: loan approval. Rule 1. If salary 30,000 rupees and credit score 700, then class is equal to approved. Rule 2. If salary 20,000 rupees, then class is equal to rejected. These rules help the model decide the correct class for new customers. How rules are created? Rules are generated by decision trees, sequential covering algorithms like FOIL, Ripper, expert knowledge. The goal is to make rules that are accurate, simple, and easy to understand. Advantages of rule-based classification. 1. Very easy to understand. Rules look like simple sentences, so even non-technical people can read them. Example: doctors can understand rules for disease prediction easily. 2. Transparent decision-making. We know exactly why a prediction was made, unlike black box models, like neural networks. 3. Fast classification. Checking if-then rules is quick, so the system works efficiently even with large datasets. 4. Works well with categorical data. Useful for data such as high, low, yes, no. 5. Easy to update. New rules can be added without redesigning the whole model. Disadvantages briefly. Too many rules can make the system confusing. Rules may conflict with each other. Hard to choose the best order for rules. Easy to remember line. Rule-based classification is equal to simple if-then rules, clear and quick decisions. Next important long question is 5. Explain support vector machine (SVM) algorithm. Support vector machine (SVM) algorithm. Support vector machine (SVM) is a powerful classification technique used to separate data into different categories. Think of SVM as a smart separating line that divides data points into classes as clearly as possible. Basic idea, super simple. Imagine you have two types of points on a graph. Red dots, class A. Blue dots, class B. SVM tries to draw a line or boundary between them so that all red dots are on one side. All blue dots are on the other side. The line gives maximum margin, maximum distance from nearest dots. This best possible line is called the optimal hyperplane. What are support vectors? Support vectors are the closest points to this separating line. They are very important because they decide the position of the boundary. If you move these points, the line changes, so SVM focuses mainly on them. Easy example, cricket selection. Suppose you want to classify players into Category 1 selected, Category 2 not selected. You plot two features: batting average, strike rate. The coach wants to separate these two groups clearly. SVM draws the best possible line between them so that future players can be classified easily. If a new player's numbers fall on the selected side, he is selected. If they fall on the other side, not selected. SVM with nonlinear data, curvy lines. What if the data cannot be separated by a straight line? SVM uses something called a kernel trick, which magically transforms the data into a higher dimension where it can draw a clear line. Example. Think of drawing a circle to separate mangoes and oranges on a table. Advantages of SVM. Works very well with complex data. High accuracy. Effective even when data has many features. Can handle both linear and nonlinear classification. Easy to remember line. SVM is equal to best boundary plus support vectors perfect separation.